In a previous video, we talked about class-based subnetting and how IP addresses could be assigned a Class A, Class B, or Class C address. But since 1993, we've not used class-based subnetting. Instead, we use classless subnetting. Sometimes you'll see this referred to as classless inter-domain routing, or CIDR. This classless addressing means that we can assign a subnet mask that doesn't fall into those same Class A, Class B, or Class C arrangements. And instead of referring to the subnet mask in its decimal form, we can simply refer to it as the number of bits. That number of bits is referred to as a CIDR-block notation. For example, a decimal subnet mask of 255.0.0.0 is the same as a /8 CIDR-block notation because it has 8 individual bits as part of the subnet mask. So it would be very common to see an IP address written as 192.168.1.44/24. Everything with the /24 is referring to the number of bits in a subnet mask, and a /24 mask would be the same as 255.255.255.0. When you're configuring a device, you're often giving it an IP address, a subnet mask, a default gateway, and very often a series of DNS servers. Most of the time, an operating system is expecting you to put the subnet mask in as a decimal mask. So for example, in Windows, you may put the IP address and then you might add in the decimal version of the subnet mask. But if you're using a router or a switch, it may be expecting the CIDR-block notation for those masks. So instead of using 255.0.0.0, you would simply input /8. Make sure you check the documentation of the device you're using to see what notation it prefers for the subnet mask. As you've probably seen in our previous examples of subnet masks, the mask consists of a contiguous series of ones followed by zeros. So the ones would be on the left, the zeros would be on the right. For example, here is a subnet mask. You can see the contiguous set of ones on the left and the zeros that are on the right. In this example, you can see 3 separate octets that are set to 1. So there are 24 ones in this particular mask, and there are 8 zeros at the end. If we were to write this out in decimal, it would be 255.255.255.0. And if you were to write this out in CIDR-block notation, you would count how many ones are associated with this subnet mask. In this case, there are 24. So the CIDR-block notation would be /24. The subnet mask is obviously used to separate the network part of the address from the host part of the address. So for this particular subnet mask, the network address is 24 bits in length and the host address is 8 bits in length. Let's convert a binary subnet mask to one that is the CIDR-block notation for a subnet mask. And we'll take this subnet mask that we have on the screen, which has all ones in the first 2 octets and all zeros in the last 2 octets. If we were to count the number of ones in this subnet mask, we have 8 in the first octet, 8 in the second octet, none in the third, and none in the fourth. That means the total number of ones in the subnet mask would be 16, so the CIDR-block notation would be /16. This means that the first 16 bits of the subnet mask are associated with the network, and the last 16 bits are associated with the host ID. Let's do another one. In this example, the first 3 octets are all ones, but the last octet has 2 ones and 6 zeros. So let's count the number of ones in this subnet mask. There are 8 in the first octet, 8 in the second octet, 8 in the third octet, and 2 that are in the fourth octet. If we count all of those together, we have 26. So the CIDR-block notation of this subnet mask would be /26. The /26 means that the first 26 bits of this address are the network part of the address, and the last 6 bits are reserved for the host ID. And here's one more. In this subnet mask, we have the first octet of all ones, the second octet has 4 ones and 4 zeros, and then the third and fourth octets are all 0. Since we are counting number of ones, we have 8 in the first octet and 4 in the second octet, and if you count those together, the subnet mask in CIDR notation would be a /12. That means that the first 12 bits are for the network ID and the last 20 bits would be for the host ID. We've looked at the subnet mask in binary and we've calculated the CIDR-block notation, but we often refer to the subnet mask as a decimal value. If we were to convert these binary subnet masks into a decimal value, there are only a certain number of these that you would run into. For example, all zeros would obviously be a decimal 0, but anything that starts with a binary of 1 and the rest zeros would be a decimal of 128. If there are 2 ones, it's 192, 3 would be 224, and so on. This means that you could create a chart that shows all 8 of the bits within a single octet and what the decimal equivalent would be. We can now use that chart to calculate the CIDR-block notation and what the decimal representation of that subnet mask would be. So let's look at a subnet mask of all ones in the first octet. There are 4 ones in the second octet, and the rest of this would be all zeros. If you refer to our chart, you can see that all ones is 255, 4 ones and 4 zeros would be 240, and then of course all zeros would be 0. And if we were to count the number of ones, we know that correlates back to a /12. So a /12 CIDR notation is the same thing as 255.240.0.0 in decimal notation. And of course, since there are 12 ones, the network section is 12 bits in length, which leaves the remaining 20 bits available for the host ID. Let's look at a subnet mask we've not seen yet. This one is all ones in the first octet, all ones in the second octet. There are 3 ones in the third octet, and of course the rest of this is zeros. If we look at our chart, we can see that of course all ones is 255, and in the octet that has 3 of these ones, we refer to the chart, that is the same as 224 in decimal. And obviously all zeros in binary is the same as 0 decimal. If we then count the number of ones in all of these octets, they all add up to 19. So your CIDR-block notation would be /19, which corresponds back to the decimal representation of 255.255.224.0. This of course means that the network part of this address is 19 bits in length and the host section is 13 bits in length. Of course, we can do this in reverse as well. Let's say that we have a subnet mask that's been given to us as a /26 in CIDR-block notation. If we were to write this out in binary, that means that we would have all ones in the first 3 octets and 2 ones in the last octet. And if we were to refer back to our chart, all ones would obviously be 255, and the last octet that has 2 ones correlates back to a 192 in decimal. So a /26, where your network ID is 26 bits in length and the host ID is 6 bits in length, is the same as a /26 in CIDR-block notation or 255.255.255.192 in decimal. Let's do another one where we've been given a /20 in CIDR-block notation. That means there are 20 ones in this particular subnet mask. So your first 2 octets are all 1, and the third octet has 4 ones and 4 zeros, and of course, the last octet will be all 0. If we refer to our chart, we know that the decimal version of that binary subnet mask will be 255.255.240.0, which is the same as a /20 CIDR-block notation. That means the network part of this address is 20 bits in length, which leaves us 12 bits available for host IP addresses.